Well, so this is the collector that I'm gonna work on with. This is a solar thermal collector. It's also called flat plate collector. It has spiral coil inside of it, and it's from Safesol, Germany, made in Germany. And the gross area is 2.18 meters square. Dimension you can see, and if it's empty then the weight is 34 kg. Maximum operation temperature is 120 degrees C, and stagnation temperature, or that in which temperature it's gonna be stagnant, that is 191 degrees Celsius. Maximum operation pressure is 10 bar. Fluid content 1.73 liter. If I fill up the pipes then it will be 1.73 liter, and fluid is normally water, but you can also try with propylene glycol. Well, so here you can see the connectors. This one is the output, and the upper one is the input. So if you put the water through this channel, then it passes like this, and then it will go to the main circuit. And the upper one is the collector, which is basically the thermal and PV together. That thing, that row, is actually the PV panel, and this one is the concentrator. This is a unique model and unique design of solar collector, and the function of this panel or this concentrator is basically to focus all the absorbing light to the main PV panel, so that it can increase its power by grabbing more sun rays from the collector. And also it has a internal circuit to cool down the temperature of this panel so that it can work perfectly and efficiently. So yes, this is the typical solar collector, or what you can say power collector. This is 70% efficiency together with electricity and also the thermal part, I mean hot water. And in the above you can see 3 different measurement instruments. 2 of them is basically the pyranometer, which basically says the irradiation, and the upper one is the global irradiance meter, that is in total irradiation, both beam and diffuse together. And the moving thing is basically the wind sensor. It collects the wind data to the control panel. And this small thing here, it's the thermal sensor to measure the temperature inside the input, and this one is to measure the temperature of the output. Now here is the typical shadow ring sensor, and this one is the same pyranometer, but it has a shadow ring so that it can calculate the amount of diffuse irradiation, and it will give the data to the control panel. Well, so this is it, and if we go to the control room then we can see more. Well, so this is the control unit of those two collector. Here you can see collector 1 and collector 2. These are two individual collectors that I have shown you outside, and this one is the control panel. Here you can see the pump main circuit, heating main circuit, borehole for cooling, and chiller is also cooling or cool water. And here everything is now switched off because I haven't run everything now. And here you can see the lab view control panel, which is designed by a German girl, and then he made the system like this. Here you can get the data like global radiance, beam radiance, and diffuse radiance from those sensors that I have shown. And also you can calculate the ambient temperature, the zenith angle, altitude, incident angle for longitudinal direction, and also transverse direction. And here you can see the two collectors, those are running, and also you have options to put collector 3 and 4 if you want. And then you can see the wind speed, inlet temperature, outlet temperature, temperature difference, mass flow, useful energy, the energy you are getting out from the collector, and efficiency, how much efficient it is. Though it is not running now, so these data are mainly the scrap values. And in the side you can also see the DC power, voltage, current, because in collector 2 you have two outputs. So you have thermal output from the thermal sensor and all the inlets and outlets, and then you have DC output that is from the PV panel, and that voltage and current will measure eventually the AC power. Okay, so if I can show you the internal circuit. Yes, those red things are basically the valves that you can operate by your hands, and these are the pipes from collector. So here you can see the chiller hot, chiller cold. So this is the chiller circuit, and if you go to there, this is the borehole circuit, borehole hot and cold. And then you have the circuit, which is basically the main circuit to fill up the water up there, and then it goes to the collector circuit. And the main circuit connection is not connected right now, so I can't show you right now. I have to connect it and then I can show. Okay, so this thing is basically another sensor, or you can say measurement meter, which used to measure the flow rate. And while you are using it, you have to calibrate it, like you have to open it up and then you have to wash it with a brush so that it can give best performance. Well, then you have all those red and those things. These are the pressure valves, actually, to control the pressure. These all are pressure valves. Yes. So basically this is it. And when you are going to measure the data, then you have to turn it on, the main switch, and everything will be automatically run by the system. So if I show you the typical diagram of the whole schematic, or the schematic diagram, This one is without dimension. This is the collected test rig of Hoxkulandolana. Here you can see all the connections, all the mumbo jumbos. Yeah, I have to study it and I have to make it my own, and I have to describe it like very elaborately. So the task of my thesis is basically to measure all the data and then to analyze some characteristics of the thermal behavior of the collectors, and also to set up a lab manual so that if anyone is interested to perform the same experiment or want to modify it, then they could start from the scratch. I mean, not from the scratch, but from my manual. It will become easy for him or her. So yeah, so this is what I'm trying to show you, the whole thing of my thesis, or you could say thesis and project altogether. So this is my lab. Here you can see a lot of things here and there. This one is another project. One of my colleagues is working on it. This is mainly the, as far as I know, the grain mill project. They're trying to develop a grain breaking device so that it can be easy. And this one is operated by solar, totally solar. And they're designing some kind of circuits and also measuring the parameters perfectly. Yes. Well, so thank you all. I'm Nafis, signing off. Thank you.